Hi, welcome everybody. This is the DevOps Summit Online. This particular session is with Daniel O. Daniel O is with Red Hat and does a lot of teaching and presentations and evangelization of many of the technologies within Red Hat and IBM. The main one that he talks a lot about is about Quarkus and all the things you can do with Quarkus and functions and Kubernetes and Knative. It's a big ecosystem, and it's actually a really good testament to the amount of work that companies like Red Hat are putting into making Kubernetes an easier thing to do. The learning curve is steep for Kubernetes, and anything that companies like Red Hat can do to make that easier for us is wonderful. And I hope that you can see during the session, is that Daniel's going to show you, is that the wonderful things you can do with Quarkus and Knative with command line using a Kubernetes cluster makes it really easy and fast to do something like serverless functions on Kubernetes. How do you do that? Well, Daniel is going to take us through that. So let me pass the baton over to Daniel and say, thank you, Daniel, for coming and sharing what you know.
Thank you so much, Jonathan. Yeah, thanks for inviting me. Yeah, it's a really wonderful day, and it's really cool to me. And then, welcome to the serverless function. We're gonna talk a little bit about that next 35 minutes. It should be fun. So for that, I'm gonna start sharing my screen, and then let's get started. Okay, right. I just found my screen. But that is the hardest part to find out. Where is a screen sharing button? Because there are millions of different the online platform, and hopefully you can see my screen now. Okay, so good morning, good afternoon, good evening, depending on where you are. And my name is Daniel O. I'm working for Red Hat, and also we're going to talk really about the serverless function, the new approach to DevApps from Quarkus to Helm. So maybe some people never heard about what DevApps is. You know what? So I've been working for more than 5 and 6 years recently to evangelize the DevOps practice and solution and platform and technology and so on. And I think the DevOps is already a major term and technology and philosophy. And now we're going to really more focus on application side, because we have already awesome and fantastic platform to bring your own application on top of DevOps platform. But is that really just a magic finger to deploy and finishing your application? That's not true. So this talk a little bit more focused on application side, but don't worry about that. I'm going to address the operator side as well. Okay, jumping into the slide. So let me talk about myself just a little bit and real quick. I am technical marketing major at Red Hat, specialized in cloud application development in terms of the Quarkus, as Jonathan mentioned earlier, and the Spring Boot, and Nodejs, the multiple cloud runtime, also infinite span like a data grid, the distributed cache, and also single sign-on, just all piece of your cloud application architecture. And out of Red Hat, I'm another duty of ambassador, such as CNCF and DevOps Institute, which make me give some more chance to evangelize and give some share my experience around cloud native architecture and tool platform and DevOps practice, etc. And then there are thousands of ways you can reach out to me, like follow my Twitter, or you can poke and steal any of my achievement in my Git repository. I'm more than happy with that. And also, I strongly recommend my YouTube channel. I have pretty tons of the technical demo and tutorial and the technical or even non-technical tips as well. Just subscribe to the channel and follow the new video and enjoy that. All right. So let's get started on actual today topic. So just let's take a one step back to understand what serverless came from and where they came from. So you know what, back in 2014, the Amazon just unleashed upon the world like Amazon Lambda. At a time, people say, well, what the heck is that? Because the Amazon Lambda is a change your infrastructure layer to run your business application. But for that, they purchase hardware, software, and build the architecture and maintain that for next 10 years. But after Amazon Lambda, they don't worry about the kind of stuff. Just go to the Amazon based on the SaaS service, and then you can just pick it up whenever you need. And then you just pay the money, like a pay-as-you-go policy, just like your mobile bill or the Netflix subscription, just like that. And then after a few years, there are more and more interesting the serverless and fast platform came up, like Google, Amazon, and Microsoft, and a lot of companies try to give some more and better serverless and fast platform for end user and enterprise companies. And also Kubernetes back in 2014, it just came up and a total game changer to change your application runtime. Previously, we just have two types of infrastructure to run the application: bare metal, physical server, and virtual machine. And now we have a container-based Kubernetes. Everybody is doing Kubernetes, no doubt. I don't want to explain what Kubernetes is. It's a silly question. And then Kubernetes provide Knative feature allows to build and manage microservice application with containerized and then running on serverless behavior. So that's the Knative on Kubernetes. And then a few years also there. So we have about 5 and 6 years. Here is the landscape. I don't want, this is from CNCF. I don't want to talk about because I am CNCF ambassador, but this is a actual de facto when you get started the serverless landscape. Yeah, this is the way. So in the serverless landscape, what do you see? There are tools, frameworks, and hosted platform, even manageable platform like an install-based platform like a Kubernetes, etc. So what do you feel? Oh, we got a lot of choices. Like you can go to Baskin Robbins, is ice cream a store. You can have more than 31 ice cream. Okay, so what do I choose today for my daughter, for my son, for my wife, for myself? It's maybe always a choice problem. So too many choices is not a good option for developer, but also even your CIO or CTO level. So here is another interesting survey. Actually, the newly made this survey beginning of last year, almost 1 year ago. As you see, there are only 6% Java application are running on Amazon Lambda, which means more and more application developer really prefer to use Nodejs or Python because it's a pretty lightweight and pretty easy. But we cannot rule Java out on your application development for serverless because there are more than 10 million Java developers out there. They are always maintain and develop new business application every single day. We cannot rule them out. We needed to keep having that people because of very smart people. And then we need to think about how Java can be feasible in serverless landscape and application development. So I'm just a quick reminder why in Java does not fit into your serverless application. So you know what, Java is 26 years anniversary. So back in there, I was there a Java developer as well. So as you see, Java was designed for high throughput with natural traffic. And then it will be expensive. Maybe you need to $500,000 to buy hardware, software, like a database or a web server, application server, etc. And also you need to more than $80,000 for each year to maintain that application architecture. So a high expense. And also once you starting your business application in your production environment, not going to happen to shutting down. It should be running all the time, like a 24/7, even Christmas and like a holidays. Your application should be running all the time, except for some security problem or operating system patch, something like that. And no one complain about the starting time. Maybe when you restart the starting time, maybe maybe just one time for 6 months or just once a year. And then it takes 10 minutes. Nobody care about that because it's a nice time for take a break, even take a nap. So that's the true in 25 years ago. And last thing is the Java designed for dynamic behavior. So if you have some experience with Java application development, you totally understand that what bytecode means. So when you build your Java application, you have a bytecode. It's not actual runnable file. You can deploy the bytecode to any JVM on any app server. That's the beauty of the Java design at a time to running a mutable system. But things changed. We already moved forward to immutable infrastructure, such as Kubernetes and a lot of the vendors, Kubernetes product like a Red Hat OpenShift as well. So this is a dynamic behavior does not a good benefit or advantage for your application development, specifically on Kubernetes /container/serverless. So we need something different. So luckily we got a new Java framework and language programming. So Quarkus is based on Java framework as well, and also allows the developer to implement cloud-enabled microservices and serverless application aligned with your event-driven application. So with the Quarkus, as you see, we have a same microservice architecture. We've got same single application, but you can change the single application anytime, whatever you need for serverless application workload. And then you can start off in millisecond when you have a native compilation. And there are tons of videos when you go to my YouTube channel. And then, but still you have the same JVM technology. That's not a change. This is one of the big roadblock of the traditional cloud Java stack. And the Quarkus make that change that this is the traditional way to build your application and deploy using the bytecode like a runnable application on top of JVM. But also Quarkus enable developer to have native compilation and native image. What is that means? Native executable file, just like executable file, which means you can run that file without JVM, like a Go and Python, something like that. And then this is the two options for developer how Quarkus make your Java application with the optimization, like a super fast starting time and also a tiny memory footprint. So let's go back to original topic agenda today, serverless. So how Quarkus address the serverless story? So first of all, Quarkus provide the Funqy features. I love this name actually. So Funqy is a new Quarkus strategy and feature provide the portable standard Java API. And based on that, the developer can write a code and deploy same application to multiple cloud platforms. For example, you can just run standalone serverless application. Also, you could deploy the same application to Amazon Lambda, or Google Function, and Azure Function, even Kubernetes, Knative, etc. So with the Quarkus Funqy, this is your simple path from writing code to deploy application as a serverless function. The first step, as always, we're going to start writing code, business logic, and some like putting your business functionality on top of your application. And then packaging, like I already mentioned earlier, like a bytecode JVM, like a standalone bootable jar file. Or you could have a native executable file, just option. And then deploy to Kubernetes cluster. This is the way how Quarkus allows you create a serverless function. And one more thing, maybe one of your operator person are really curious about though. So what Quarkus gives some benefit to my job, like an operation team. even he or she is not, he is part of the DevOps team, but they are still really curious about what Quarkus benefit when we adopt that technology to build serverless application and maintain that. So here is a Helm chart. So Helm chart is one of the popular project to make some compilation and maintenance your application environment and runtime on top of the Kubernetes. This is one of the day-to operation duty on DevOps team, specifically operator side. So, but for that, maybe you have some magic script or some kind of YAML file to specify what kind of compilation you have to define, like how many pods should be deployed, and what kind of imaging I need to pull down from Docker registry or company inside the registry, or what kind of secret or what kind of complement will be bind into my application. All compilation can be defined in Helm chart, and then you can make some kind of template based on the Helm chart. Just imagine that when you install some software in Linux operating system, maybe you can familiar with the packaging manager such as DNF or Yum. This is all software installation and maintenance packaging manager tool. So Helm chart is a similar thing on Kubernetes. And now Quarkus also built in a Helm chart. So the operator team on DevOps team can easily to use Helm chart to deploy and manage your Quarkus application. So let's say I am DevOps engineer, a little bit more focused on operation side, but I want to make some standard template to deploy Quarkus application runtime on my production environment running on top of Kubernetes. And this is a predefined template, make it easy to build your own Helm compilation. So I'm not going to stop. I'm going to stop the talking anymore. So let's jump into the demo, how it works. So there are lots of ways to build and deploy and manage your Quarkus application for serverless. But today I'm going to show a pretty simple way to using CLI command line. So there are KN command line. This is the Knative serving command line, short name KN. And the KN, actually there are Funq, the function command line is already embedded in KN command line. So you can go to KN, and this is a command line, KN Funq, and then create the Quarkus Funq. This is a function name, and then I'm gonna to using runtime Quarkus. So once you create this one, I just execute one single command line, and then Quarkus Funq create Quarkus name and the runtime Quarkus. And let's try to. Okay, so now I will have the same the Quarkus Funq Maven project just created for me. So when you check this out, you can see. Okay, let's try to delete this one because I think like duplicate the nested folder. I can try to that. Just create one, and now you can have, and then Quarkus Funqy, and then as you see, you have a just generated Java project, and then you can use any Java editor like a VS Code and IntelliJ to change any app, change business logic or put in the business logic in this project. Let's try to use the Java editor, the VS Code. So once you open the file, and then here's the application. There are a lot of pop-up here. Okay, I'm going to like zoom in once again. Okay, so in a main root directory, you can find the one YAML file. This is the secret source. We can deploy this application and packaging application to OpenShift or even vanilla Kubernetes. As you see, the function name here, Quarkus Funq, And then the runtime Quarkus, I'm going to talk a little bit about what is different. There is just so many different runtime will be served with this command line. And then trigger HTTP and the builder, and there are default, JVM, native, etc. Okay, so go back to terminal console. And the next step, I'm going to deploy this application. Just let's say when you go to this application, you can find the sample application here. So sample application function, and you can see here the only func annotation. This annotation makes your Java method as a function. Pretty simple. No need to any particular business logic. Just one annotation, the func, and then this is the input output, just JSON message, the simple like hello world stuff. And then let's say I'm not going to change anything for this demo, but feel free to add any business logic when you go through on your hand. So back to the command line. As the next step, I'm going to just deploy this application. So once again, kn the command line func, and then I'm going to deploy this application, and I needed to define the external container registry, because once I build this application, and then I needed to push this containerized application to external registry. This is just a normal workflow, how to build and deploy your container image on Kubernetes. And then I just define namespace in Kubernetes side, like a Quarkus, func, and barbers here. Just for that, here is my OpenShift cluster, the REST version 4.7 based on Kubernetes 112, 120. And then here's the Quarkus func, the namespace, and there's no resource here. So I'm going to deploy my function into this namespace. So just run this command line. Oh, I got some error. Okay, I need to go to right password, the right directory, go to Quarkus, because I need to run this command line with the based on the func YAML I just showed that, right? So once again, I just run this one. So behind, oh yeah, I just forgot it. I need to run my local container machine. This is the beauty of the live demo, isn't it? So in the meantime, so I'm going to show you quickly what kind of more argument or tool you can use that with the kn func. For example, when you create multiple way, so for example here, you can specify your runtime. In this demo, I'll use the Quarkus, but you can also use Go and Node.js and Spring Boot as well. So because as you say, I'm really a Spring person, no worry. So you can use the generate your Spring project, and then we will use a Spring function to deploy application to Kubernetes. And also triggering by default HTTP like a RESTful API, but also you can trigger by CloudEvent like a Kafka messaging or syncing or ping, something like that. So because there's some request, like a request response type, or the other one, or synchronized stuff. Okay, back to the container is just running on, and deploy the application. So in behind the scenes, we use a build pack, so one of the open source project to build your application and packaging, containerize, and then deploy your Kubernetes cluster. It takes a minute, or it depends on how many business application you have. So in the meantime, let's go back to VS Code and open up the function YAML file. As you see, the namespace automatically updated based on the command line, right? The Quarkus func and the image name automatically change that based on my command line. And then the other all empty like image digest will be replaced soon enough. And this is the how CLI works for application development and building and deployment. So go back to terminal window. Yeah, it's already application built. And then we just waiting for Knative service to become ready. Go back to OpenShift console. Now you can see here. So your application is almost running here. And then just click on Bureau, you can find that your JVM or the Quarkus just starting, and it just takes 1 second to start up. And you go back to here. And then you can run the command line, and you can invoke REST API. For example, here is our endpoint. And let's try to invoke, just test to the argument. For example, the message should be JSON format in this example, like a OpenShift serverless with the Quarkus and DevOps online summit 21, a little bit longer. And then okay, try to one more time. Should be too long. Okay. Then what is the endpoint here? So, but fire this endpoint. Let's go back to my OpenShift container platform. So this application actually running on serverless, which means this serverless function will be scaled down to 0. By default time is 30 seconds. This is the exact behavior or serverless function. If there are any other request like on demand. So let's try to give some little bit more time. Okay, we application just scaled down. And then when you run this application and back to this application automatically scale up. So this is the way how your function works. When you deploy the Quarkus application as the native compilation, it should be pretty much faster than JVM application. Back to here, we got the return code here. The OpenShift serverless with the Quarkus at DevOps Online Summit 2021. Pretty awesome. And then if we have more time, I want to actually showcase how to deploy native compilation as well, but we don't have enough time. So please go to my video channel and you can find more detail. So let's go to another demo. Here's another project like a Quarkus Helm. There's no topology here. When you go to a Helm chart, and then topology view, actually you could add any Helm chart here. And then you can find the Quarkus and install Quarkus chart. And you could have some defined image and also build like a JVM mode or a native mode. And also you can put in the Git repository when you use, when you build this application. This is a sample application like a hello world stuff. And then native compilation, deploy compilation, and something like that. So I'm not going to change anything, just leave it default and just install this application. And then it takes a couple of minutes to build and deploy an application. So your Quarkus application with a nice logo, but don't worry about maybe you gotta find out you got some error messaging. But when you go to Helm chart, and then there are the release notes, and you can find that. So you might have some report like an image error pull or image pullback up until the build is complete. So which means go back to our topology view and click on build. So your build is still running. So at a time we gotta clone our Git application pod and then compile like a Maven build and then containerize this application using Podman or Docker build, something like that, and then deploy this application to Kubernetes. This is not actually serverless by default configuration, but you can change that when you tweak your Helm chart. But I want to say you can, for operation perspective, you can define Helm chart to make a standard template as a Quarkus runtime. And after that, your developer keep changing the application side on top of the Helm chart. So this is the way how to manage your Quarkus runtime on top of DevOps platform like a Kubernetes, and to define standard runtime configuration, just like old style magic script or install guide, etc. Okay, so I think it's just done. And then you click on the endpoint, you can do the landing page here. And then here's the endpoint, like a hello. I'm gonna make it bigger. And then you can, another thing, so like a greeting and like a Jonathan. And then, hello, Jonathan. This is really cool, lovely, right? Okay, so I'm gonna stop my demo and back to my slide deck, and then I just try to wrap up today's talk.
Right.
So just a few minutes. Here's a more use case and demo. Go to Bitney, Daniel TV. You can find a more realistic use case. For example, you can run function based on Quarkus as a front-end application. You can also have a back-end application like your data store, like a data grid. And then when you got some incoming network traffic from outside to inside the front end, and your front end serverless Quarkus function will be scaled up automatically in 1 second. And then that data keep storing your backend discrete data, but your backend data grid will be scaled out just like a Kubernetes behavior. And after maybe 30 seconds, 1 hour, there's no more network traffic, and your front-end application scaled down to 0, like idle, hibernated. And then your backend application will be scaled into a default, like a 2 or 3 application. So this is the beauty of scalability and flexibility using serverless. And in the end, your company have some cost saving and more efficient operational benefits. So the big point is still Java. As you mentioned earlier, so Node.js and Go and Python, pretty awesome for develop serverless and function, but still the most popular language is still Java. There are more than 10 million people still struggling with the application development with the Java technology, including myself. So if you're really more interested in Quarkus journey after DevOps Summit, here is the way. There are IDC report. Maybe you can find more some performance metric to compare the other traditional Java framework. And also there's a separate running portal, Bitney try-Quarkus. You don't need to install any software, just go there and you can browser-based running portal like a Katakora. This is actually Katakora running portal. We put in the tons of the Quarkus story here. And here's a project generator like a Spring initializer and code.quarkus.io. You can get starting your Quarkus application development from here. Okay, I think I'm done, and then I'm actually here for answering and addressing the live question. So hopefully you enjoyed the talk, and thanks for attending.
Thank you, Daniel. This is excellent. I learned a lot in watching this. There were many details in here that that's very illuminating. So I really appreciate you going through all these. I have a couple of questions, if I could ask, and we're not live, so you know, it's relying on me to answer to ask the questions. Some of the things I want to get a little more clarity on is the Quarkus is an engine. There's lots of serverless engines that you can run on top of Kubernetes. Quarkus is not the only one, but is that a correct way of also describing Quarkus? It's an engine that's running on top of Kubernetes that's doing serverless?
No. Actually, Quarkus is not engine. Quarkus is a framework, like the Java framework, like a Spring, or another framework like a Python. It's a language programming framework. So you can run any application, not just serverless. You can develop the traditional microservice application and cloud-native application, event-driven application, and serverless application. But more important thing is, so once you create the traditional microservice application, but still you can evolve existing microservice application to serverless with the Funqy annotation. No need to change the business logic, just putting that annotation on top of your method, and the Quarkus auto-wire your traditional microservices to serverless.
Right. So the traditional thing of Knative, or originally it was building, serving, and eventing.
Yeah, that is
the building
platform. Yeah, exactly. And then we have a more integrate and interface with the Knative stuff as well.
Right, excellent. Now you mentioned, I'm really keen on this one. I talk about this thing called the distillation pattern, making sure that your containers are distilled down to the fact, so because you're playing on Kubernetes, and if you deploy bloated containers on Kubernetes, ultimately that's going to wind up to be money for you, cash, Bitcoin, whatever your currency is, it's going to cost you. And you want to make them as small as possible. Not just the container image size, but also the amount of CPU and memory that your application is actually consuming. Startup time is a big part of that. Your attack vectors for security is part of your distillation pattern. Quarkus is solving many of these. One of them that I'm interested in is the, I think you mentioned compile native. In your slides, you were talking about you could use the Java hotspot, but you could also use compiled code. In other words, this is kind of a new concept for a lot of Java engineers. It's like, wait, you can actually compile your Java to native?
Yeah. So native compilation is based on using the GraalVM technology.
That's what I want
but actually they're running on the substrate VM, not using whole entire GraalVM. So Red Hat actually support the downstream of GraalVM to code out the Manjaro. We created the downstream in the Manjaro, engineer with the OpenJDK with some security and performance, something like that. Right. So you can use actually same building tool like a Maven or a Gradle command line, but with some specific argument like a profile native, and then you can have the executable file, and you just run that file without Java command line. So previously, yeah, go ahead.
So with Quarkus, it will actually compile. It'll take care of getting your Java code compiled to binary.
Exactly.
Good. Yeah. But not Spring Boot, right?
Yes, Spring Boot actually announced this week about Spring Native is still better. And then they have a plan to GA around September or October time period.
Good.
This year. But you know, so we already started the native compilation stuff almost 2 years ago. So you know, so it's pretty much different. There are tons of different metrics and data. So that's why I recommend the IDC report. It's a free download. You can find all comparison between the Quarkus native compilation and JVM mode versus even Spring Boot and the other framework stuff.
And so the transition from going from a Spring Boot way of doing annotations and things is very transmittable. Like as a Java developer, it's pretty easy to make that transition from a Spring Boot annotation framework to a Quarkus type of framework, right?
Yep.
I mean, Funqy is.
Yep. And then we also provide some migration toolkit for free.
Okay.
Yeah. So you can just upload your Spring application and just click on that. And we analyze all detail how to migrate. But you know, so Quarkus all depend on own Java stack. I mean, standard Java specification. But you know, so some feature is not equivalent to Quarkus because it's Quarkus built on event-driven technology.
Right.
So more reactive and more faster. So it's totally different architecture.
Right. Static build. It's a build time at static, not a
exactly. Yeah.
Dependencies at runtime. Exactly. Yeah. It's. I'm glad to see there's a lot of work continuing to be done on this, and your demonstration makes it look very attractive and easy to do. So I'm excited to do more stuff with it. Yeah. You mentioned the if anybody wants to learn more about this, the Red Hat did some really nice Kata scenarios on learning Quarkus. Not just learning Quarkus from development standpoint, but also getting it running on Kubernetes. And you can do that in these sandboxes on katacoda.com and was it learn.openshift.com or
run.openshift.com, or just go to directly Quarkus.bit.ly/try-Quarkus.
Yeah. And a couple minutes, these are little vignettes. They're like 15 to 30-minute little tutorials. And then you start trying those as a developer. It's pretty easy to get to start.
Yeah, exactly. Yeah. Fundamental and advanced scenarios. Yeah, pretty fun.
Awesome. Good. All right. Anything else, Daniel? I think we covered it.
No, I think I'm done. And then hopefully you enjoyed this topic and enjoy the rest of the summit.